The edges of a cuboid are in the ratio 1:2:3 and its surface area is 88 square centimeter. What is the volume of the cuboid? Well, we have been given the ratio of the edges of the cuboid. So I can say that length can be equals to 1x, the breadth can be equals to 2x, and the height can be equals to 3x. X being the constant, so that the ratio remains the same. Now we have been given the surface area. Now from surface area we can find out the value of x and thereafter the value of L, B and H. Let us write the formula for surface area of a cuboid. So we have twice of L times B. So let's write it. L times B is 1x times 2x, that is 2x square. Plus we have B times H, that is 2x times 3x, that is 6x square. Plus HL, that is 3x times 1x, that's 3x square, right? So we have 2 into 6 plus 2 is 8 plus 3 is 11. So 11x square, and that is equals to 22x square. Well, we have been given the surface area, that's 88. Okay, so we can calculate x square. So x square is equals to 88 by 22, and that is 4. Therefore x is equals to under root of 4. Therefore I can say x is equals to 2. Now that we've got the value of x, we can find out what are the values of L, B and H. So the length is 1x, that is 2, and the breadth is 2 times 2, that's 4, and 3 times 2, which is the height, that's 6. These all will be in centimeters. Now we want to calculate the volume. Well, volume is equals to L times B times H, and that is equals to 2 times 4 times 6, isn't it? That's 2 times 6 4s are 24, and 24 times 2 is 48. The unit will be centimeters cube. So that's the volume. Option B. Find the length of the longest rod that can be placed in a room 16 meters long, 12 meters broad, and 10 2x3 meters high. So let's say that this is the room, and this is basically a three-dimensional figure of a room. So the rod, if it should be longest, it should be the length of the diagonal of this room, right? Then only it can be the longest. If the rod is longer than this diagonal, it cannot fit in this room. So basically we want to calculate what is the length of this diagonal. So we've been given the length, breadth and the height of this room. The length is 16 meters, the breadth is 12 meters, and the height is 10 2x3. That can be written as 10 times 30 plus 2, that's 32 by 3. So this is 32 by 3. Well, the formula for calculating the length of the diagonal is equals to the under root of L square plus B square plus H square. That is the under root of addition of squares of the length, breadth and height. So we have the values. Let's put those in and calculate the value of D. So this is equals to under root of L square, that is 12 square plus 16 square plus 32 by 3 whole square. This is equal to 12 square is 144 plus 16 square is 256, and plus we have 32 square, which is equals to 1024, divided by 3 square is basically 9, right? So we have this thing ready. So this is under root of 400 plus 1024 by 9. Now this can be written as 4 9s are 36, so this is 3600 plus 1024 by 9. 4624 divided by 9. Taken the root of that. Now root of 9 is basically 3. What is the root of 4624? Well, if you calculate that, you'll get it as 68. Okay, so you have 68 by 3, and that will be equals to 22 2/3 meters. So we have our answer option B. How many bricks, each measuring 25 centimeters by 11.25 centimeters by 6 centimeters, will be needed to build a wall which is 8 meters by 6 meters by 22.5 centimeters? Let us consider that the total number of bricks required are n. Now if I multiply n by the volume of one brick, it will give you the volume of the complete wall, isn't it? So we have n times what is the volume of one brick? Well, a brick is 25 by 11.25 by 6 centimeters. So we can write it as 25 into 11.25 into 6, length into breadth into height, isn't it? This is equals to the volume of wall. Well, the measurements of this wall are given in meters. So let's convert those into centimeters. So 8 meters is 8 into 100 centimeters times we have 6 meters, which is 6 into 100 centimeters, times we have 22.5 centimeters. So let's put it as it is. So 22.5. So this 6 and this 6 goes out. We can cut this 25 and this 100. 25 times 4 is 100. So we have n is equals to 8 times 4 times 100 times 22.5 divided by, we have 11.25. Now if you multiply 11.25 by 2, you will get 22.5. So 22.5 divided by 11.25 is 2. So we have 8 times 4 times 100 times 2, isn't it? 8 times 4 is 32, and 32 times 2 is 64, times 100 is 6400. So we need 6400 bricks to make up this wall. Option C. 50 men took a dip in water tank 40 meters long and 20 meters broad on a religious day. If the average displacement of water by a man is 4 cubic meters, then what is the rise in water level of the tank? So this is the tank in which 50 men took a dip on this religious day. Let us say that the amount of water or the height of water that rose is h. Now we can get this height by calculating the amount of water that is displayed. That is, by calculating the volume of water that is displayed. In other words, we have to calculate the volume of this shaded cuboid. Okay. So what is the volume of water displaced? Well, the volume of water displaced by one man is 4 cubic meters. So the total volume displaced is equals to the total number of men times the water displaced by one man. That's 50 times 4, and that's 200 cubic meters. So that's the volume. Well, volume is equals to L times B times H, and that's 200 right now. Okay, L and B is given, H we have to find. Length is 40 times breadth is 20 times H is equals to 200. Okay, this 0 and this 0 and this 0 and this 0 gets cancelled out. We have 2 and this 2 cancels out. H is equals to 1 by 4, and this will be in meters. Well, that is equal to, 1 by 4 is 0.25 meters, and 0.25 meters is basically 25 centimeter, isn't it? So the rise in water level is actually 25 centimeters. That's option B.